So recently I had a question proposed to me. How can we have a single volume in a scene that controls different scenarios based on which way the player enters and exits from? In this instance, we wanted a volume that could control musical transitions. When the player entered the volume, the music would die down, and depending on which of the four ways the player exited, a different track could play. Now, the easy answer to this is create an actor with a box overlap, and whenever the player enters or leaves the box, just do some vector math with their location and figure out which side they came out on. This worked fine, but I wasn't super happy with it. One issue that it does pose is in the editor window, you can't actually tell which way the box is facing. So when you actually want to use the box, you have to keep track of its orientation yourself, which is not very user-friendly. No worries, you can just add some arrow components to the actor, and then you'll always be able to tell which way the box is facing. But the main issue with this whole system is it's not very modular. Because it's an actor, we can't really just attach this to whatever we want and get the direction in an easy way. We're calculating all of that in the actor itself. So my proposed solution was instead create a custom box component that has its own visualizer and can return the directional info on the overlap event itself. This means the component could be attached to any actor and used in all sorts of different ways. So it started off looking like this, turns into a much nicer solution. Now I won't go into the source code in explicit detail, but there are a few changes I want to point out. The most important being that in the prototype, we were passing the actor's location in every time an overlap began or ended. The problem with this is in the scenario where the actor's origin location is different than the overlap location relative to the box, we can get inconsistent results. And this is due primarily to having to take into account the bounds of the box itself so we can have any shape we like. The good news is, on the begin overlap event, we actually get a sweep hit result, so we can actually just take that impact point and pass that in instead of the actor's location, giving us something more accurate. The bad news is, on the end overlap event, Epic does not give us a sweep hit result, so instead we can just make one ourselves by getting the overlapped component and doing a shape sweep against it. While this won't give us perfect results in every scenario, it's really the best option we have without modifying the engine code. Now, a few other changes you may have noticed are creating an enum as opposed to using an fname to get the directional info, and also creating new delegates and broadcasting them within wrappers for the begin and end overlap events. This allows us to get the directional information from a blueprint event, or we can bind directly to the delegate. So here I have a demo scene set up that has a few different ways this box can actually be used. First, we're going to look at this one in the middle here. So as you can see, I've got this scene spread into 4 different zones. And what this box is going to control is the post-processing, lighting, and sound of each one of these zones. So let's take a look under the hood here, and we'll see what's going on. So whenever the player enters the box, we're going to set some default values. Like I said, on post-processing, the position of our skylight, as well as fading out any music. Now, when the player leaves the box, we have a map of the enum we created earlier and a structure called sky data that has our post-processing info, a sky position, and any music we want to play. Depending on which way the player exited the box from, we're going to blend in one of those collections of data. And you can see down here we've got those blending timelines. So let's see what that looks like in our scene. Now, an important takeaway from this is there's only one volume. We don't have 5 different overlaps for 5 different zones in the scene that are determining these settings. We essentially have one zone, which is our central safe space, call it, and the other areas are defined totally by their orientation to the central zone. If we want to change how any of these zones feel, we can simply tweak some of the settings in our map, or even just rotate the box. Another situation in which this proves useful is the creating of some puzzle mechanics. So here we have a puzzle where the player needs to touch this rune block on different sides in a certain order, and it'll move along these points. A concept that I definitely did not steal from the Deoxys event in old Pokemon games. So when the player touches the block, we're going to use our box component and make sure that we're touching the right side in the order that we need to be touching it in. If we are, we're going to move to the next point. If not, the entire puzzle will reset. A final puzzle design that utilizes this box component is a type of forced maze, where the player is required to follow a path that is invisible to them. Here we have our box component set along turns and intersections on this pathway. The player is required to exit through the front of each box, creating an invisible pathway they must follow around the docks. With the help of our visualizer, it's very easy to see what path they have to take. If they take the wrong path, they'll simply respawn at the start of the docks. A huge thank you to Curtis Smith's Sound for tasking me with this project, as well as all the music and audio for the demo. If you'd like to try this out yourself, I've put up a plugin on GitHub. Just download it and drop it into the plugins folder on your Unreal Engine project. The component also has some visualization settings exposed, so you can play with those to your liking. If you found this video helpful or entertaining, please leave a comment and be sure to give me a follow, as I'll be posting similar content in the near future. Thanks so much for watching.